All right, displaying frequency. So we're going to talk about displaying frequency. Frequency is the number of times a data item occurs. Okay, a data item just means what you're looking for. So if we're talking about grades and you get like 5 grade hundreds, then the 100 counted 5 times. 100 is a data item. The frequency would be 5 because it happened 5 times. So data item is just something you're looking for. Sometimes it's not numbers. Sometimes it could be hair color or color of M&Ms or shoe size or anything. It's just how many times a data item could occur. A line plot displays the frequency by using X's for each time it occurs. So here's an example. Here we have make a line plot for these human body temperatures, degrees Fahrenheit, 98, 99, and so forth. So what you're going to do is make a line. Here's my line. What's my smallest value? Well, 96 is my smallest value, so I'm going to start with 96. My biggest value is 100, so end with 100. So I'm going to go to 97, then 98, 99, and then I have 100. 100 is kind of far out there, so I'm going to kind of move it back in. There we go. 100. Alright, now I'm going to put an X every time I see that number. So 96, how many times does it occur? 1 time. 97, once, twice. 98, once, twice, 3 times, 4 times, 5 times. And then 99, once, twice, 3 times, 4 times. And then 100, 1 time. So here's my line plot by using frequency. So that's all there is to it. The reason why I do this is so I can see like trends. Like I can see that most of these are going to be around this area. So my median is probably going to be 98. My mean will probably be pretty close to the same thing because all my information is right here, 98 and 99. And that's pretty much it. I mean, I can actually figure out range and everything from here. So it's just a way to show frequency. All right, another way to show frequency is by using a frequency table and a histogram. So a frequency table is just a way to organize the data, and the histogram is a way to pretty much present the data. So I've kind of already started this one. It said, some brands of batteries last longer than others. Make a frequency table and histogram for the data on hours of battery life. So here are my hours on battery life. 12, 9, 10, so forth. Make a frequency table. The data range from 9 to 22. Use equal sized intervals that begin with multiples of 5. So as you can tell, over here, I made from 0 to 4, which is 5, because 0, 1, 2, 3, 4 counts 5s. And then 5 to 9, 10 to 14, 15, 19, 20, and 24. Those all have intervals of 5. And then we're going to make a histogram once we're done. So this is what a frequency table looks like. I have my categories, my hours, and then a tally mark. So a tally mark is just like putting in line. Y'all have all done this before. So 0 to 4, how many numbers do I see from 0 to 4 up here? Well, none. So it doesn't get a tally. How about from 5 to 9? Well, there's 1. And that's it. So just 1. 10 to 14, 1, 2, 3, 4, 5, 6, 7, and then 8. And then 15, 19, 1. And then 21 and 22 will be down here. So the frequency is how many tallies you have. So here we have 0. We have 1, 8, 1, and 2. So a frequency table helps you gather the data. Now we're going to present the data on a histogram. So let me draw my histogram. I have an X and Y axis. On the X axis, it's always going to be your time, or what's given you the frequency. It's your independent. And your Y axis is the frequency. Alright, now I have 6 categories of time, so this one's from 0 to 4, 5 to 9, 10 to 14, oops, 15 to 19, and 20 to 24. And then, because I go all the way up to 8, I'm going to count by 2s. 2, 4, 6, 8. Now I'm going to actually make my bars for my bar graph, my histogram. So 0 to 4 has 0 frequency, so we don't even make a mark. 5 to 9 has 1, so I'm going to go up to 1. There it is. 10 to 14, without any spaces, I'm going to go up to 8. So right here, I'm going to go all the way up to 8, come right back down. 15 and 19, 1. 20, 24, 2. And that's what my histogram looks like. This is another way to show trends. So my mean and median will probably be right here on the 10 to 14 range. That's pretty much it. Alright, last thing. Venn diagram is a diagram that uses circles or regions. Sometimes it doesn't have to be circles, but most of the time it is, to show how sets of numbers or objects are related. So here we have a soccer coach who's working on a lineup for our next game. The team has 15 players, so 15 in all. That should be all the circles combined. And it says 10 players on the team are good at offense. So what I'm going to do is put 10 right here. Then it says 6 of those players are equally good at offense and defense. So, but it said 6 of those players, 6 of the 10. So what do you think happens to this 10 right here? Yeah, it loses 6. So 10 minus 6 is 4. There's only 4 players left over there now. Now defense says 11 players are good at defense. But you forgot about the ones who are good at both. So we have to subtract 6 from 11, which gives us 5. So if we did this right, if we add up all of our numbers in our circles, we should get 15. 4 plus 6 is 10, plus 5 is 15. Works out perfect. So, that's it. Now you can answer questions. How many players are good at offense? There's 10 of them, because those are the ones that are covered in the green circle. How many players are good at defense? 11. That's how many players are in the orange circle. How many players are good at both? 6, because that's how many players are in both circles. See, it's pretty easy once you draw the diagram. So let's do one more Venn diagram, and then we'll be done. A softball team has 18 players. 14 players bat right-handed, so 14 right-handed. 2 players can bat both left-handed and right-handed. So remember, 2 of them can do both. So that means I'm going to have to subtract that from right-handed. Now you got to pay attention to wording because this next sentence gets you. 4 players bat only left-handed. So I'm not going to subtract because that does not include these 2 because it says only left-handed. If I did this right, we should add up to 18. 12 plus 2 is 14 plus 4 is 18. Works out. So how many players bat left-handed? 6. How many players bat right-handed? 14. How many players bat both? 2. How many players only bat right-handed? 12. How many players only bat left-handed? 4. See how many different ways you could ask questions for this one? So you got to be careful when you make these. They're pretty easy to read, but making them is a little tricky. That's it, folks. Get it? The end. E is included in both. Get it? That's funny.